In the last class, we have studied about the static and dynamic memory allocation, and we have also seen that how the memory is allocated dynamically and what problems can be arises while allocating the memory dynamically. And the two problems are memory leak problem and the dangling pointer problem. Now the next topic is linked list. Now linked list is nothing but an alternative of array. It is just like array, it also stores the homogeneous data, but it is an alternative. Now in array, I have told you that it uses the continuous memory allocation scheme. Contiguous memory allocation. And array is used in such type of application where the memory requirement is static. For example, let's suppose an application requires 100 MB of space. Then it will require this 100 MB for all time. If the requirements changes from time to time from 100 MB to 200 MB, then it is not possible in array, because we cannot change the size of the existing array. Also, let's suppose an application requires 100 MB of space, and in your memory slot you have not 100 MB of contiguous memory. You have obviously the over all the 100 MB of memory space, but it is contiguous. Let's suppose 25 MB is present here, 25 MB is present in second chunk, 25 MB is present in third chunk, and 25 MB is present in fourth chunk. Then even if you have the 100 MB of space available in your memory, but it is available in 4 chunks. So since there is not the contiguous memory available of 100 MB, the compiler will deny to allocate 100 MB of space if you are using the array for this problem. Now in linked list uses the different memory allocation scheme that is called the non-contiguous memory allocation scheme. So in non-contiguous memory allocation, if you have available 4 chunks of 25 bytes of the memory, what the linked list will do, it will connect all the 4 chunks. Let's suppose we have used 25 MB of space here. Again, when this space is completed, it will use 25 MB of space here, and it will store the address of this chunk in this chunk. Again, it will use the 25 MB of space, and it will store the address of this chunk in this chunk, and finally this chunk will be used and the address of this chunk will store in this chunk. So linked list have two disadvantages. All the two demerits which the array have, it uses the dynamic memory allocation scheme. Dynamic memory allocation scheme. Mm. So in dynamic memory allocation scheme, if your required size is changes from time to time, you can use the realloc function, and this realloc function will allocate some memory, or it will change the existing chunk from 100 MB to 200 MB. And if you want to add some new chunk, you don't want to extend the existing memory, if you want to use the a chunk of 100 MB, a new chunk of 100 MB, the both will be joined. Okay, so linked list is useful in this manner. So first, the problem of varying size of memory, varying size of memory is overcome in the linked list technique, as well as if the memory is available, if the memory is available scattered scattered, then linked list will use all scattered memory. So we are going to the linked list. Linked list is first point, it is a linear data structure. I have already told you in the initial classes when I've taken your lecture 1 at the very start of the August. I've told you about the what is the linear data structure. It is a collection of similar type element. Why this? Because it is nothing but the alternative of array. So it uses the concept of array. It also stores the similar type data, similar type elements. Now each element, usually called node, an element in the linked list is called node, and this node comprises of two items. This node comprises of two items. First one is, this is wrong, here is data. First one is data, and second one is address to the next node. Something I will tell you, because this link I have done here, I have produced this link in the same way this link is here. So in an linked list, the basic element is node, and node has two parts. First is for data and the second is for address. Okay. Now what are the drawbacks of the array? What are the drawbacks of the array? The size of array is fixed because it is allocated at compile time, and at the runtime we cannot change the size. This is the first drawback. And the static memory allocation can cause the underutilization and overutilization of memory. underutilization and overutilization of the memory. Now what is underutilization? Let's suppose I have allocated 540 MB 540 MB for a application, and the application is using only half, that is 220 270 MB. In that case only 270 MBs are used and 270 MB are unused. So this is called the underutilization of the memory. You have not fully utilized your memory. And the second scenario, let's suppose you have only 100 MB of space, but after many time the application requires 250 MB of space. So requirement here increases, and in this case this is called the overutilization of the memory. Now again, the third problem is insertion and deletion of element are expensive in array. Why? Let's suppose I have given an array of size 10. And I want to store a new element at this address. So what you have to do, I have to shift all the elements here. This element will be shift here, this element will be shift here, and finally we can store the element here. So these many type of shifted we have to perform in order to store an element at the desired location. In the same case, if we want to delete this element, then we have to shift all these elements back. So in that case we can say that insertion and deletion in array is expensive because we have to perform various shift operations of the element. Various shift we have to perform. Now what is the advantage of linked list? Efficient memory utilization. Why? Because we can allocate the memory using the malloc function according to our requirement at runtime. Let's suppose right now I want 100 MB. I'm putting 100. Again after some time we want 50 MB. We are putting 50. As per our requirement we can allocate the memory, or as per our requirement we can deallocate the memory. So memory utilization is very efficient in the case of array. Insertion and deletions are easier and efficient. Now how it is easier and efficient I will tell you later. I will explain this point later when I will explain the linked list diagrammatically. Okay. Extensive manipulations. Extensive manipulations means we can perform complex operations, complex calculations we can perform very easily. Since insertion and deletions are very easy, so extensive manipulation we can do. We can perform the complex calculations. Okay. And the fourth advantage is arbitrary memory location. As I have told you, you are using the malloc function, and malloc function will occupy the memory arbitrary. It is not necessary that it will allocate the memory at a specific location. It can allocate the memory at any location. Disadvantage of linked list. There are some disadvantages also if it has advantage. The first one is, due to the use of extra pointer, we have to perform extra space. For example, if we are taking an array of 5 element, then let's suppose it is taking 5 into 4, that is 20 bytes, if the size of integer is 4 byte. In the case of linked list, since we have to, along with the data, we have to store one pointer. So here one element is taking 4 byte, but here what will happen? Here along with this 4 byte, some spaces is also required to store the pointer. So here one element will take 6 bytes of memory. Okay. Can't access randomly. I've told you that array can be accessed randomly. For example, you want element number 5, you can directly go to the element number 5. If you want to access element A8, you can directly go to element A8. But in linked list, this random access is not possible. In linked list, sequential access is done. Means in order to go to a third location, we have to move from first to second, and after that we'll go to the third location. That is called the sequential access. Again the same thing, nodes are stored incontiguously, greater increasing the time required to access the individual element within the list. If we want to access an individual element, we have to traverse all the element previous to that element, and then we have to perform the access. But in array, we can directly go to the desired element. Again, doubly, the problem in the linked list is that the backward traversal is very difficult. We cannot traverse backward. In the case of singly linked list, I will tell you later that what is singly linked list. But in case of singly linked list, the backward traversal is not possible. And doubly linked list somewhat easier to traverse in the backward direction, but it will take some extra space. Let's suppose this data size is taking 4 byte. I will tell you later all these 2 points, that what is doubly linked list and what is singly linked list and what are the disadvantages. Because when you will study the type of the linked list, then only these points will be cleared. So till now I understand that all these points are clear. If we have no clarity about the memory size, if the memory size is not clear, then we have to go for the non-contiguous memory allocation scheme, and linked list technique is used here. Linked list. So I have already told you in previous that basic element of the linked list is the node. Node has two parts. First contains data and second contains address. Okay. In C compiler, now how to declare, now the question arises, how to declare this node structure. In C compiler, we have only limited type of primitive data, that is integer is primitive data, character is primitive data, float is primitive data, boolean is primitive data type, and so on and so forth. But there is no any data type, primitive data type, which is capable of describing this structure. For example, compiler knows what the integer is. We have not to define the structure of integer. Compiler knows in advance that it takes the two bytes of memory. The definition is already known. So the data types whose definition is already inside the compiler knows the definition of data type. Those data type is called the primitive data type. What are the non-primitive data types? Those data types whose definition is not inside the compiler. So we have to create a data type for this node. We have to create the data type for this node, because when we define this node, we must have the data type of this node. So whenever the user define the data type, that are called the non-primitive data type. So here you can see that this structure has two parts. First one is data. It can be integer, it can be float, it can be character, anything. And here is address. And then question arises that how to define this. These two are in dissimilar fashion. So to define two dissimilar type of data inside one data type, we are going to use the structure. Like whenever we define the student data, we write like this: struct stu char name 20 int roll number dash dash dash. So what you are looking, structure is a variable, and this structure has till now two parts. First part is name and second part is roll number, and we are able to store this. Okay, so same thing, you can see these two are dissimilar type of data. So how to define the structure? Here we have two parts. First one is data and second one is address. Now the linked list is of this form. Let's suppose one node is created here and second node is created here. Now whenever talking about one node, it has two parts. First part we have written struct is the keyword to defining the structure. Name is the name of the node. Name of the node is node. Now this pointer will be not here. This is wrong. This is wrong. Int data. So the first part will contain integer type data. This block is nothing but this block is data variable, and we can store integer type data. Now what this instruction is, the next is nothing but a pointer type variable. This is a pointer type variable. So it will store the address. And whose address it is going to store? This is going to store the address of this block, this element. And the starting address of this whole element, let's suppose is 2000, then it will store 2000. Now what this 2000 indicate? This is indicating the node. And this node is nothing but defined by struct node itself. So what I have written? I have written struct node asterisk next. What its meaning is? Its meaning is this next is a pointer type variable which is going to store the address of a node type block. So this will store this address. So whenever you have to ask that write the structure of a node, what you will write? You will write struct node integer data. Recorded. Struct node pointer next. This data is indicating first block of the array, and this next is indicating the second block of the array, and it is storing the address of whole node. Okay, so this is what the structure of a node. Now type of linked list. Linked list is of mainly three types, that is singly linked list, circular linked list, and doubly linked list. Again one more linked list is there, doubly circular linked list, but I will tell you later. I have not written in the type, but it still is there, doubly circular linked list. Now see the graphical representation. See the graphical representation of a node. So this is the singly linked list, and in this singly linked list, these are the basic blocks. For example, this is A, this is B, and this is C. Let's suppose it is stored in address 2000. It is scattered, it is not contiguous, so you need not to worry about the address. This is 3500 and this is 7000. Scatteredly all the blocks are allocated. So what will happen? This 35 is stored inside this address. This 7000 is stored inside this address, and that's why this link is created. And this 200 is stored inside the head. This is the graphical representation. So whenever you want to traverse this linked list, you will start from the head pointer. This head is a pointer type variable which is storing the address of the first node of the list. Because we will traverse from the first node itself, so somewhere we have to keep the address of this node, and this address is stored in the head pointer type variable. So when you are going to traverse this linked list, then you have the head variable initially. You don't have anything, but you have only the head variable. And with the help of this head variable, we can traverse all the linked list. How? In the head, what the address is? 2000. So by reading the content of this head variable, we can directly move to the 2000 address. And the value of 2000 address, the data value of the 2000 address is A itself. So when we move here, we can read this, we can read this also. So initially the content is A. Again, in the next pointer, next variable, we will see the address, that at what address I have to move. I have to move to the 3500 address. So we'll move to 3500 address. The content will be read as B. Again, we will take this 7000, and this 7000 will move here directly. We do not need this link. This is for our convenient. But using 7000, you can move 7000 directly, and you will read C. And finally, at the last of the link, last node, the pointer variable is null. This is ground, that is null. So while traversing the linked list, you can see in order to read the data C, we have to traverse from A and B, then we can reach the C data. So the traversal is in linked list is not random. Traversal is what? Sequential. Okay. So let's see the next point, what this is indicating. I have written struct node. I have everywhere used this pointer, but this is wrong. Cross it. Struct node integer info, struct node pointer next and box. So when you create the student, you have variable 1, you have variable 2, you have variable 3, and dash dash dash, and finally you have written something like Assis. So this Assis is nothing but a structure type variable which is going to give his name, his roll number, his mobile number, his address, and all these. So Assis is a variable here. In the same way, whenever we write struct node integer info, struct node pointer next and box, then box is a variable which is defined by two part. First part is info part, and the second part is next part. This is box, and obviously this box is defined statically. Okay, because we have not used any malloc function. In order to declare this box, we have not used malloc function. So this is just like a structure. This is structure. What is structure you have used? So I have written, let's suppose I am writing it cleanly. This is info and this is next part. I have written box.info. Box.info means you are talking about this block, and you are putting here the value 5. Box.next is equals to null. You are putting null. Why null? Because this next is of pointer type variable, and it will contain null. It will not contain any integer value. It will contain the null. Now, in the second declaration, okay. In the second declaration, what I have written, I have written B1 and B2. Struct, let's see, struct node is already defined. Struct node is defined with using this block. It has two part struct node. First one is info and second one is next. So whenever we return a struct node B1, B1 is a variable whose data type is struct node. But struct node is not the primitive data type, it is user defined data type. So the compiler will start finding its definition. And its definition is here. And it has two parts. First one is info part and second one is next part. So here B1 is here. Again we have written struct node B2. A more block will be created with the name B2. Its type is struct node and struct node is of two part. First one is info and second one is next. Now B1.info is equals to 1. So 1 will be assigned here. B2.info, B2 is this block and info is its first subpart. Then B2.info is equals to 2. B1.next is this part. What we are doing, we are storing the address of B2. B2 is indicating the block number, the element number 2. B2 is indicating the element this node, and the address, starting address of this node is, let's suppose, 2000. So what we are doing, we are sending the address of 2000, that is 2000, inside B1.next, and B1.next is this. So 2000 will be assigned here. So 2000, this block is indicating this address only. So this arrow will be created. So what is the problem here? We have written struct node B1. This is just like static allocation, because static allocation like int x. We have written int x. So this is static allocation because size is known in advance. So here when you write struct node and definition of struct node is already given, then compiler will know the size in advance, because this is 2 byte and this is 2 byte. Let's suppose it is taking 4 byte. Let's suppose. So the size is 4 byte. This is known in advance, and its size is 2 byte. This is known in advance. So both the way of nothing but this static memory allocation. Now how to dynamically allocate? How to dynamically allocate the node? So in the case of integer, when we are talking about integer, we are writing size of int. Size of int. So when we are going to allocate a node, we will write here size of node. Not only node but struct node, because This node is defined by a keyword that is known as the struct. So size of struct node will give the size of the node. Obviously the node has two parts. First one is info part and second one is next part. So this size of will return the size of the node, and this whole parameter is passes to the malloc function. Let's suppose the first block is taking 2 byte and this is also taking 2 byte. So this will, the size of struct node will be 4 byte, and this 4 byte is passes to the malloc function, and malloc function will create a node of 4 byte. The starting address of the node is 2000. First two block is responsible for storing the address, is responsible for storing the data, and the last two block is responsible for storing the address. Okay. Now what the malloc function will do, it will pass the address. It will pass the void address of this block, of this node. Now what is the void starting address? That is the 2000. So malloc function will throw the 2000. Now what the 2000 is? Here the 2000 is address of the whole block, because it is the starting address. The block is allocated with a size of 4 byte, and the first byte is 2000. So the malloc function will throw the 2000, and 2000 is a pointer type variable, pointer type value. This is address. So it will be stored in a variable. So what we are doing, we are storing this 2000 in a variable that is called PTR. Now the question arises that what should be the type of this variable? Since this is the address of a node, then this must be the pointer of struct node type. This must be a pointer of node type, and the definition is given using the struct node. Its type should be struct node. Struct node pointer. So the overall, when we combine these both things, what will have happen? We can write struct node pointer PTR is equals to malloc size of struct node. Okay. So this is throwing the address 2000, and 2000 is the address of a node. So it will store in a pointer type variable whose type is node. Okay. So what will happen? Here we have created a block of 4 block, and 2000 is thrown from here, which is stored in a pointer type variable PTR whose value is 2000. Now we want to store, I have already told you that first two block is responsible for data and next two block is responsible for address. So whenever we want to store in this info, since in the last thing you have seen, in the last representation, this B1 is not allocated separately. This is the name of this block. Okay. So whenever we are using this block, we use the dot operator just like in structure, because b1 is the name of this block itself. So whenever we write b1 dot info equals to 1, means we are overwriting this block. Whenever we write b1 dot next is equals to 2000, means we are overwriting this block. So this is the name, it is not separately created, this is the name of this block itself. But in the case of linked list, what you are looking, this is created separately, this is not the name of this block. So whenever you want to access the data and the next part of this, the info and the next part of this, you have to use the arrow operator. So ptr arrow info is equals to 5, ptr arrow next is equals to none. So what will happen? These two block will store the address, will store the value equals to 5, and these two blocks will store the address which is equals to, right? So in the case of dynamic memory allocation, when you want to access the elements of the linked list, you have to use the arrow operator, not the dot operator, because dot operator is used in structure or union, but the arrow operator is used in the linked list in order to access the blocks of the node. Okay, so next, here let's see some example. For example, here A is 2000, 5000, 7000. Obviously it will store the 5000 address, then only it is pointing this node. Obviously it will store the 7000 address, then only this is pointing this node. And this, the address of this node, that is 2000, is stored inside the head. And this heads is a pointer type variable of node type. Okay, because it is storing the address of a node. Then head arrow info, head is this, obviously head is containing 2000. So what we can write, 2000 ka info. What's its value will be? When you print this value, obviously 2000 का info क्या है आपका 7 A, so it will contain A. What is 2000 का next? The next part is 5000. What is the content of start? Not start here, head. Start I have written, but this is head. Though then content of head will be, what is content of head? This is 2000. And what is the address of head? Obviously the content is 2000, and this variable will also be created at some memory location. Let's suppose it is created at 1000 memory location. Then address will be 1000. Then this is how this graphical representation can be compiled, and it's The value is respectively A, 5000, 2000 and 1000. So this is what called singly linked list, because in singly linked list we have a node, and along with a node we have a address bar. So in singly linked list, a node contains two parts. First one is data and second one is next. Since we have arrow in only this direction, so we can move in this direction. But there is no any pointer in this direction, so we cannot traverse backward. So what I have told you in the disadvantage of linked list, that singly linked list we cannot traverse in backward. So operations on the singly linked list. Now linked list is also a data structure, and in data structure what we have to study? We have to study different type of data structure and the operations that we can apply on that data structure. So operation in singly linked list is something. First one is create a box. Box matlab create a node. Now already the structure I have defined earlier. Whenever you define the structure, it will be something like that. Struct node. This is the struct keyword. In order to define the structure, this is the node. Name of the structure, integer info, struct node, pointer next. So this is the structure of the node. Now in order to create a node, we know that we have to call the malloc function. So what we have called? We have called the malloc function, and the size of the malloc function is equals to the struct node. So the malloc function will create a node whose size is equals to struct node, that is the size of this part and the size of this part, the sum of the size of this part and this part. So what this malloc function will return the starting address of this block. Let's suppose 2000. So what will be the return type of this function? Return type is struct node pointer. Why struct node pointer? Because we are throwing an address of a node. So if a function is throwing the integer value, it is integer, its return type is integer. If it is throwing the character value, its return type is character. But if it is throwing the address of a node, its return type will be node pointer. Okay, so this is what the create a box or create a node. Okay, insert in front of linked list. For example, this is the operation. Whenever we are talking about a singly linked list, for example, I am writing like this: head, so first of all, in order to insert a node in the linked list, first of all we have to create a node. So creation of node, I have already told you that how to create the node. And in the case of the insertion of a node in the linked list, there are three types of insertion is possible. First one is insertion in front of list. Means we are adding a new node here at the front of the list. Insert at front. Insertion we can also perform at a specific position or in between. Specific position or at the last of the list. So for example, at this head, I want to add a node 5 here. Since this is the 1000 address, this is 2000 address, this is 3000 address. Whenever we want to add a node in front of the linked list, what you have to do, you have to, okay, I will tell you in the next class. I think this is sufficient today, and in the next class I will tell about how we have to insert in front of the linked list. Okay, so insertion are possible, I will tell tomorrow lecture. Okay, thank you.